Welcome. Today we're going to explore how the building industry can shift from a wasteful linear model to a more sustainable circular approach. Buildings consume vast amounts of materials and generate enormous waste. In this presentation, we'll focus on circularity in buildings, especially the power of reusing construction materials rather than throwing them away. We'll see how designing disassembly and reuse can significantly cut waste and environmental impact. By the end, you'll understand why reuse is a key strategy in making construction more sustainable and how it fits into the bigger picture of a circular economy for buildings. We review the same slide in other circular economy videos. Let's start with the basics of the circular economy as it applies to architecture. The traditional take, make, dispose process shown on the left relies on raw material input and generates waste. The recycling economy improves the linear economy by recycling demolition materials, but the process still generates waste when full material recovery isn't achieved. The circular economy on the right minimizes reliance on new raw material input by keeping resources in use for as long as possible. Achieving net zero waste is possible in the circular economy through reusing and recycling construction waste instead of sending it to landfills. The diagram in this slide illustrates levels of circularity in construction, from recycling materials left to reusing entire buildings right across the horizontal axis. Each stage brings greater environmental and economic benefits. Circularity in the built environment means keeping building components in use as long as possible and minimizing waste. Recycling of materials converts old building materials into new ones, which reduces waste but offers the lowest environmental and economic benefit. Reuse of elements salvages components like doors or windows to preserve their value and avoid fabricating new elements, a bigger benefit than recycling materials. Reuse of systems keeps major systems like the structural frame to save materials and maximize gains. Reuse of modules allows for assembly and disassembly of entire modular units, such as prefabricated rooms, which cuts new material use. Adaptive reuse of buildings involves repurposing entire buildings instead of demolishing it, eliminating waste and new material needs. A net zero waste strategy means designing a building system where ideally no waste goes to landfill. To achieve this, architects apply the reduce, reuse, recycle, regenerate hierarchy at every stage. First, we reduce material use and avoid excess. Please refer to the circular economy. Reduce video for more details. Next, buildings are designed to reuse construction materials whenever possible. This involves effective connection strategies for easy disassembly and assembly. Reuse is our focus in this video. Recycled materials are implemented where reuse is not feasible, such as crushed concrete or broken windows. Refer to the circular economy. Recycle video for more info. Finally, regenerate encompasses materials that generate new raw materials and restore ecosystems. Refer to the circular economy. Regenerate video for more info. By implementing reduction, reuse, and recycling, the building industry can drastically cut waste and move from a linear system to a truly circular one. Slides 4, 5, and 6 showcase an example of a building that is designed for disassembly and reuse. Not a single item had to be sent to landfill. The People's Pavilion in Eindhoven, Netherlands, is a landmark example of circular building design. Created by Bureau SLA and Overtreaters W for a design event, this 250 square meter pavilion was built using 100% borrowed materials from the concrete foundation blocks and wooden beams to all the glass panels and even the facade cladding, as shown here. After its 9-day use during Dutch Design Week 2017, the entire structure was taken apart and every piece was returned to its owner. In other words, nothing was wasted. The People's Pavilion proved that it's possible to construct a functional, beautiful building with zero new resources and zero waste by planning for disassembly and reuse from the start. This slide shows the installation of the pavilion. The connections are all mechanically connected, allowing the pavilion to be taken apart without breaking its members. This diagram illustrates the modular unit and components. A modular building system or modular unit means creating a building out of standardized units that fit together. These units are often manufactured off-site and are flat-packed for efficient shipping. They can be easily assembled, disassembled, and reassembled easily for different building constructions. This approach ensures a circular approach to the management and life cycle of our buildings, since modules can cycle through different projects instead of heading to a landfill. One key principle for making buildings reusable is to use reversible connections or mechanical connections in construction. Because of these reversible joints with tongue and groove and/or mechanically fastened connections, the structural system could be easily assembled, disassembled without damage, and reassembled in other buildings. Slides 8, 9, and 10 illustrate the urban village projects as modular, reused building units. This slide shows a circular economy approach from the housing level. Modular timber housing blocks are fabricated off-site for fast construction with minimum waste. They can be easily added to or taken apart as needs change and are designed for disassembly and assembly through the entire life cycle of the buildings. This slide looks at a circular economy from a community lifestyle perspective. The Urban Village Project aims to make city life more affordable and sustainable through shared living and pooled resources. This reduces extra resource extraction by limiting unused and underutilized goods and services. Here, the Urban Village Project is visualized. People live in a network of adaptable, eco-friendly homes with shared services, making sustainable living become convenient and cost-effective. This project shows how circular economy principles in architecture, modular construction, material reuse, and resource sharing can create not only sustainable buildings, but more affordable and connected communities. This video was supported by UNC Charlotte in collaboration with the US-ASEAN Smart Cities Partnership. For further inquiries, please contact Kyoung-Hee Kim at UNC Charlotte. Let's work together towards a sustainable future through circular economy practices in the built environment.